White phosphorus is one of the many allotropes of pure phosphorus. It is made by heating phosphate rock, silica, and coke in a furnace at 1450 centigrade. The phase diagram shows that white phosphorus must coexist with gaseous and liquid phosphorus, and depending on conditions, white phosphorus can coexist with red and black phosphorus. White phosphorus is a crystalline solid and a single crystal, which has a tetrahedral structure of the P4 molecule. There are two different crystalline forms known, alpha and beta. Above 195.2 degrees Kelvin, the alpha phase is stable under standard conditions and has a body-centered cubic structure. When below 195.2 degrees Kelvin, the phase becomes the beta state with a hexagonal crystal structure. White phosphorus has a point effect of grain boundaries, but it does not contain heteroelemental wrong bonds, so it does not affect the properties of white phosphorus, which is soluble in organic solvents and insoluble in water. It does not diffuse in water, so it is usually stored underwater to avoid spontaneous combustion with air, allowing it to be stored and transported. White phosphorus has 4 atoms, forming 3 bonds per atom with bond angles of 60 degrees. These angles are formed using weak intermolecular forces, van der Waals forces, giving white phosphorus a low melting point of 44.1 degrees Celsius. Due to weak bonds and 60-degree bond angles, white phosphorus is metastable, spontaneously igniting in air around 35 degrees Celsius. This metastability causes white phosphorus to be the least stable, most volatile, and most reactive allotrope of phosphorus, making it very interesting to us. Because of the volatility of white phosphorus, it is used primarily as an incendiary weapon in grenades and artillery shells. It is also used as a smoke screen because it scatters visual and infrared radiation. This is white phosphorus.